So now that we have described a polynomial from equations, I want to describe it from a graph. So remember the different things when we go to describe a polynomial that we might want to do. Okay, we might want to name the function, which is our degree. We might want to say how many possible solutions there are. We might want to say how many possible turning points do we have. I'm just going to call it turns here. And then we might want to talk about that end behavior. Again, I'm just abbreviating over here. So remember, the possible solutions came from the word solution, which was the same as the x-intercept. Okay. Turns came from taking that in and subtracting 1. End behavior came from the arrows, or what the ends of the graph are doing. So where are the arrows at the end? Okay, so let's see if we can come up with that here. Okay, so let's look at this first one. Now, it doesn't matter which order. I think typically when I'm looking at a graph, the end behavior is the easiest thing. So I'm going to look at the end behavior. I'm going from the bottom down to up, which means that my end behavior is going to fall to the right. Oh, sorry, don't know my directions there. Sorry, it's going to fall to the left, and it's going to rise to the right. Okay. Now, I can figure out how many turns. So I see I'm turning 2 times. So the turns, there's going to have 2 turns. Now, if I'm going backwards and I know how many turns there are and I want to go back to intercepts, I can either look and see, well, where is it crossing the x-axis at? Well, it's crossing 1, 2, 3 times. So I can either count it like that, or I can say, well, instead of saying n minus 1, let's add 1 to this, which will give me 3 possible solutions. Okay, so I have 3 possible solutions. And remember, the number of possible solutions is also the degree of the polynomial. Okay, so we're going to get that same idea as we go through the rest of these. Okay, let's look at this next one. So here, my end behavior is going to be down to down. So it's going to fall left and right. Okay. Then I'm going to have 1, 2, 3 turns. Now, if I look at this, it looks like it only is crossing the x-axis at 3. However, we know that the turns has to be n minus 1. Therefore, there must be 4 possible solutions. So that's why we say we want to look at not only how it's crossing the x-axis, but notice here I'm sitting on the axis, and we'll talk about that later. That's going to do something different. Okay, so we said here, if it's sitting, it's going to count twice. So that's how we end up with 4. So this one counts as 2, and then I get my 3rd and my 4th one there, right? So that means it's going to be a 4th degree polynomial, all right? Next one here, let's take a look. My end behavior is up to down. So that means it's going to rise to the left and fall to the right. Okay. I see 1, 2 turns, which means that if I add 1 to that, I should have 3 x-intercepts, or 3 solutions, and I see them 1, 2, 3. So I'm going to have 3 solutions, which means it's a 3rd degree. Okay, so let's look at this last one here. I've got my end behavior is up, up. So that means it's going to rise, left, and right. Okay. Possible turns. So let's see. I've got 1 turn, 2 turns, 3 turns. So I've got 3 possible turns or turning points, whichever one you want to call it. So I know that I should have 4 solutions. 1, 2, 3, 4. 4 solutions, or x-intercepts, or roots, whatever you want to call it, which means it would be a 4th degree polynomial. Okay, so now I should be able to describe a function from not only the equation, but also from a graph as well.